we will now finish with an example of a new distribution called the multinomial distribution. So suppose that a basketball player who shoots 70% from the free throw line takes 2 shots. Remember that we've calculated the probabilities of scoring 0, 1, and 2 points, and those are 0.09 for 0 points, 0.42 for 1 point, and 0.49 for 2 points. Now suppose that that player gets fouled 10 times in a game, and therefore gets to shoot a pair of free throws 10 times. Let x0, x1, and x2 be the number of times that the player makes 0, 1, and 2 free throws respectively. We want to find the probability that the player makes 0 free throws twice, 1 free throw 3 times, and 2 free throws 5 times. So we're going to start by just doing the example where the player the first time makes 0 free throws, the next time makes 0 free throws, and then 1 free throw, 1 free throw, and 1 free throw, and then finishes with 2 free throws each time for the last 5 attempts at the free throw line. So because the free throws are independent, we can assume that this probability is 0.09 squared times 0.42 cubed times 0.49 to the 5th. But that's only one way that x0 can be 2, x1 is 3, and x2 is 5. So we should calculate the number of ways x0 is 2, x1 is 3, and x2 is 5. So what we can do is take the 10 free throw attempts and choose 2 of them to be the number of times that the player makes 0 free throws. And then from the remaining 8 attempts, we can choose 3 of them to be the number of times that the player makes 1 free throw. And then the remaining 5 times the player will make 2 free throws. So this turns out to be 10 factorial over 2 factorial, 8 factorial times 8 factorial over 3 factorial, 5 factorial. Now you'll notice that the 8 factorials cancel, and that's actually 10 factorial over 2 factorial, 3 factorial, 5 factorial. And I'm going to use some new notation for this. I'm going to write 10, and then I'm choosing 2, 3, and 5. So here we will say that the probability then that x0 is 2, x1 is 3, and x2 is 5 is going to equal the number of ways that the player can make 0 free throws twice, 1 free throw 3 times, and 2 free throws 5 times, times the probability of making making 0 free throws twice, 1 free throw 3 times, and 2 free throws 5 times. So in this, I introduced what's called the multinomial coefficient. The multinomial coefficient is n choose k1, k2, all the way through kr, and that is defined to be n factorial over k1 factorial, k2 factorial, all the way down to kr factorial. And then using this idea of the multinomial coefficient, we can actually define the multinomial distribution. So if we consider an experiment with r possible outcomes that occur with probabilities p1 plus p2 plus all the way down to pr equals 1, so all the sums of the probabilities have to be 1, Then we can let x1, x2 through xr be a random vector that counts the number of times each outcome occurs. In our previous example, we were counting the number of times that the player made 0 free throws, 1 free throw, and 2 free throws. Then x1, x2 through xr has what we call a multinomial distribution, and its probability mass function is the multinomial coefficient n, choose k1, k2 through kr, p1 to the k1, so that's the probability of success being p1, and we're going to have k1 successes. The probability of the next success will be p2, and we're going to have k2 of those successes. And then finally, all the way down to p sub r, the probability that we succeed for xr, and we're going to have kr of those successes. And here, k1 plus k2 all the way down to kr has to equal n, the number of trials. Okay, now that we have this new distribution, let's figure out the marginal distribution of x2. So we're going to let x2 equal basically our success. And that would mean then that x1 plus x3 all the way down to xr would be like failure. So then the probability of success is going to be p2, and the probability of failure is the sum of the other probabilities. P1 plus P3 plus all the way down to P sub r. Now, if we add up all the other probabilities, then that should be the same as 1 minus P sub 2. And so the marginal distribution for x2, so the probability that x2 is some number k, well, if x2 is like success and all of the other events are like failure, then this should be a binomial distribution, n choose k, p2 to the k2, so this is n choose k2, p2 to the k2, 1 minus p2 to the n minus k2. So x2 is a binomial distribution. So if you have a multinomial distribution, then each of the marginal distributions for x1 through xr are binomial distributions.